Hi everybody, so this video is going to be about solving rational equations. This is the last section that we're talking about in chapter 7, and in the next video we'll move on to chapter 8. Okay, so the first thing we're going to do is review something that you guys have probably seen before. Okay, and this is solving proportions. Okay, so I want to remind you what makes something a proportion is that you have an equation with one fraction on either side. Okay, for example, right, something that looks like this, where you have one fraction equals another fraction. Okay, so this is a proportion. And when you have a proportion, you can solve by cross multiplying. So I think you guys have seen this before. Okay, and now you have just a linear equation, so we're going to multiply this out. Okay, move all of our y's to one side. Okay, and divide by 7. All right. All right. So let's do one more of those. And then we'll move on to some stuff that maybe is a little bit more tricky or we remember it a little bit less. Okay, so we're going to use the same method. We're going to cross multiply. Okay, so we're going to multiply this out. Okay, now because we have x squared here, we want to move everything to one side and try to factor. Okay, and now we're going to try to factor this. Okay, factors like this, and this is going to give us our one solution, x equals 1. Okay, it's called a repeated solution because it comes from each of these two factors, but you still are only going to get one solution here. Okay, so let's talk about solving rational equations that aren't proportions. Okay, so here's our plan. So the first thing we're going to do is factor all of the denominators. Okay, and the reason that we want to do that is because we're looking for the LCD. Okay, so we're factoring the denominators to let us find the LCD. Okay, now we're going to multiply the LCD on both sides. Okay, and at this point you should have no more denominators left. Okay, so this method actually clears away the denominators, and that's what allows you to solve. So because you're multiplying by the LCD, everything from the denominator should cancel out, okay, and you should have no fractions left after this step. Okay, then you're going to solve normally. Okay, and then the last thing you're going to do is check for extraneous solutions. Okay, so remember, extraneous solutions are solutions that you get from solving correctly, but they're like fake solutions. They don't actually work when you go to plug them in. Okay, and we'll talk about what type of extraneous solutions you get from these, but just to remind you, that's what those are. Okay, let's look at an example of using those steps. Okay, now you can see this isn't a proportion because this right side has two different terms. Okay, so you can't cross multiply here because what would happen to the 1? Okay, now the denominators are already factored here, right? There's only these two denominators and they're already factored. So we can see that the LCD is going to be x plus 1. That's really the only denominator you see here. Okay, So what we're going to do now is we're going to multiply everything you see by the LCD. So we're going to multiply here by x plus 1, we're going to multiply here by x plus 1, and we're going to multiply here by x plus 1. Okay, now here and here, that's going to cancel the denominator, but here it's not going to do anything. So here I'm going to have 2, here I'll have x, and 1 times x plus 1 is x plus 1. Okay, so like I said, after that third step, you can see that there's no denominators here, and you can just solve this normally. Okay, so I'm going to get x equals 1/2. Okay, all right. Now here's how you check for extraneous solutions. You can plug it in and make sure that it works, okay? But even faster than that, what you're really checking for here is, does this make the denominator 0? So when I plug in 1/2, I would get 1/2 plus 1, that's 3/2, okay? So that means this isn't an extraneous solution. If you get an extraneous solution here, it's one that will make the denominator 0. Okay, so that's what you're checking for. All right, let's do another example like this. Okay, again, this isn't a proportion because of this plus 3, okay? And again, the denominators are already factored, okay? So our LCD is going to be x minus 3, okay? Because that's the only denominator that we see. So we're going to multiply every term by x minus 3. Okay, so here on the left, this x minus 3 in the numerator is going to cancel this one in the denominator, and same here. This one from the numerator cancels that one from the denominator. Okay, so here I'm going to have 5. Here I'll have x plus 2. Okay, and here I'm going to have 3 times x minus 3. Okay, and now I can solve this linear equation. Okay, I'm going to combine my x's and my constants. Add 4 to both sides, and you would get x equals 9/4. Okay. So again, when you're checking for extraneous solutions, you're really checking if this makes any of the fractions 0 in the denominator. So if you look, okay, if you plug in 9/4, 9/4 minus 3 is not going to be 0. Okay, so this is an okay solution. It's not extraneous. All right. Okay. Let's look at some examples where it's a little bit more complicated. Okay, and really the only thing that can get more complicated here is, what is the LCD? Okay, so the first thing I'm going to do is factor this denominator. The other denominators are already factored. Okay. All right, and then I'm going to say that my LCD is each of the factors that you see here, so 2 and x minus 2. Okay, and then I'm going to multiply every single term by 2 times x minus 2. Okay. Okay, so here we go, and we're going to cancel every single common factor. So here our x minus 2's are going to cancel. Okay, here our 2's are going to cancel, and here the 2 is going to cancel with the 2, and the x minus 2 is going to cancel with the x minus 2. Okay, so what's left? Here I have 2 times 3. Okay, here I have 1 times x minus 2, and here I have just 2x minus 7. Okay. So again, if you use the correct LCD, you shouldn't have any fractions left after that. Okay, so let me combine my like terms. Okay, and I get the solution x equals 5. Okay, so when I check my denominators, if I plug in 5, I'll get 5 minus 2, which is 3, not 0. Here the denominator's 2. Here I would get 5 minus 2, which is 3, times 2 is 6, not 0. Okay, so this is an okay solution. All right. Let's see another one like that. Okay, these denominators are already factored, okay? And what's important about this example is even though these denominators look similar, they don't have any common factors. So when you find the LCD, you really have to multiply them together, okay? So the LCD is 3x times 3x plus 1. So just because these look similar, don't let that fool you. They don't have any common factors. You have to multiply them together, okay? So I'm going to multiply everything by the LCD. Okay, including this side. Okay, so here my 3x is going to cancel with my 3x. Okay, so I'm going to have 4 times 3x plus 1. Okay, here my 3x plus 1 is going to cancel with my 3x plus 1, so I'm going to have 3 times 3x. Okay, here there's nothing to cancel, so I'm going to have 2 times 3x plus 1. Okay, and now 0 times 3x plus 1 is still 0. Okay, so now I'm going to multiply this out. Okay, and now I'm going to put my terms in descending order and combine like terms. Okay, so for x's, I have 12 plus 9, which is 21, plus 6 is 27. Okay, and then I have 4. Okay. All right. Now I want to be able to factor this, right? So it's good that everything is here on the left. Okay. So I'm going to try 9x and 2x. Okay. So because of this 2, I can't put 2 or 4 here. So I'm going to have to put 4 here and 1 here. So let's see if that works. 9 times 1, 9 plus 8 is not 27. It's 17. Okay. So that's not going to work. So let's try 6 and 3. Okay. So again, I can't put 2 or 4 here because it would have a common factor. So I'm going to put my 4 here. Okay, and then I'll put my 1. So here I would have 24 plus 3 is 27. Perfect. Okay. All right. So this would give me, that's an x, 2 solutions. Okay, and here's where it really comes in handy to remember what makes something extraneous, okay? So for these ones, you don't have to plug these in and check them all the way. You just have to check that they're not going to make the denominator 0, okay? So here only 0 would make this denominator 0, and here only -1/3 would make this denominator 0. So that means both of these are a-okay, and these are both solutions. Okay. Let's do a couple more examples. Okay, so the first thing I'm going to do is factor the denominators. Okay, so for the LCD, for the numerical part, I have 3 and 6, so my LCD is going to be 6. Okay, and then for the polynomial part, my only factor is x plus 1, so I'm going to include that. Okay, so I'm going to multiply everything here by 6 times x plus 1. Okay, so here my x plus 1 is going to cancel with my x plus 1, and I'm going to get 6 times 2. Here my x plus 1 is going to cancel with my x plus 1. The 3 here will cancel with the 3 here, and I'll get 2. Okay, and here 6 is going to cancel with my 6, and I get x plus 1. Okay. So I get my solution, x is 13. Okay, now you can see that the only thing that would make these two denominators 0 is x equals -1. Okay, so this is a perfectly good solution. Okay, let's do one more. Okay, so I'm going to factor this denominator here. This is the difference of squares. Okay, so I'm going to multiply by the LCD, which is this, 2x plus 3, 2x minus 3. Okay, same here. Okay, and same here. Okay, so in the first term, my 2x minus 3 is going to cancel with my 2x minus 3, and I'm going to have 4 times 2x plus 3. Okay, in my second term here, this is going to cancel with this, and this is going to cancel with this. Okay, so I'm just going to have 4x. Okay, and here my 2x plus 3 is going to cancel with this, so I'll just have 2x minus 3. Okay, so let's multiply this out. Okay, so we're going to combine our like terms. Okay, so we're going to look at what would make the denominator 0 here. Okay, so if you look here, if you plug in 3 halves, negative 3 halves, you would have the 2's canceling, right? And then you would get -3 minus 3, which is -6. That's okay. All right. But here, you would have -3 plus 3, which is 0. Okay. So this is actually an extraneous solution. Okay, because it makes the denominator 0 for this fraction and this one. Okay, so because our only candidate solution was extraneous, this actually has no solutions. Okay, if you were to get 2 solutions and one is extraneous, the other one is your solution. But because we only have one candidate and it turned out to be extraneous, this equation has no solutions. Okay. I hope that you guys have seen this before and this is just kind of a quick refresher for you. If that's not the case, let me know. We can do some more examples, but I'll see you guys soon.